All right, so we have the Pythagorean theorem. So we're going to be spending a lot of time on right triangles over the next couple of weeks. It's going to start with the Pythagorean theorem, and then we're going to move on to special right triangles. Okay? We're just going to be in general right triangles right now, but then it's going to move to a little bit of trig. And so you really need to understand what we're doing now so that we can build on it as we go. Okay? So on a Pythagorean theorem, a squared plus b squared equals c squared. We've heard that 100 times. Maybe 1,000. But just to make sure you understand, C is going to be the hypotenuse. And the hypotenuse will always be the longest side. Okay? The hypotenuse will always be the longest side. We're on the other side of the paper. The hypotenuse will always be the longest side. And if you're not sure which one is the longest side, it'll be across from the right angle. So this right here is our hypotenuse. It is obviously the longest side of this triangle. It is also across from the right angle. So that's how we are doubly sure. Right? The other two sides of the right triangle, you have your hypotenuse are legs. Now, later on, I'll want you to label short leg and long leg. So if you want to label them now, you can leg 1 and leg 2. Or you can call it short leg and long leg. But if they're the same size, then it doesn't matter which one, you just call them leg and leg. So the Pythagorean theorem is basically says that if you take the length of leg 1, or the short leg, and you square it, leg 1, and square it, and you add the length of the other leg squared, the square of the length of the other leg, you should get the same number as if you took the length of the hypotenuse and squared it. So the A's, the B's, and the C's, trying to go by A, B, and C may not always work, because sometimes they'll call it X. Sometimes they'll call this over here H, and that stands for height, not hypotenuse. So you're going to get a bunch of letters. So if you try to stick with A, B, and C every time, it's not always A, B, and C. It's leg squared plus leg squared equals hypotenuse squared. Why'd I put a C? Leg squared plus leg squared is always equal to the hypotenuse squared if it's a right triangle. Okay? So, example 1. Draw a little right triangle and label the legs 12 and 35. Doesn't have to be proportional. Just make a right triangle. It kind of looks like a right triangle. Okay, don't make something that looks like this and call this the right angle or something. You know, make it pretty obvious which one is the right angle. And your legs would be 12, 35 inches. We're trying to find the length of the hypotenuse. So, legs squared. One of the legs is 12. The other leg is 35. So we're not sure the length of the hypotenuse. We'll call it H for hypotenuse. So, we start to evaluate. 12 squared is 4. 35 squared is that. Okay. Oh, that was supposed to be squared. So then, the next step in solving for H would be to add these two together. What? I'm not sure what that means, but hold on. 1,000. Let's just add it up. I'm trying to do this in my head and I can't get it. So, how do I find H? If H squared is 1,369, how do I find H? I have to find the square root. Now, all the other classes, somebody always said divide by 2. And it's a common mistake. Make sure that you take the square root. Dividing by 2 is not the same thing. So in your calculator, you have to do second x squared, I believe, to get to the square root. Second square root, 1369. Because when you take the square root of h squared, you get h. How much? 37. So h is 37 inches. All right. That's the length of our hypotenuse. We have another picture. So draw a triangle, ABC again, similar to the one we just drew. Label one leg 20 and label the hypotenuse 29. So it ought to look something like this. 20 feet, 29 feet, and then we got to call this something. We'll call it H. The hypotenuse is always going to be opposite the right angle. So then, I'm going to plug it into the Pythagorean theorem. This time it would look something like this. A squared plus 20 squared is going to equal 29 squared. All right? 20 squared is 400. A squared plus 400 is equal to 841. Now subtract 400 from both sides. A squared would be equal to 441. And then to find the length of A, now don't put 441 over here as your answer. It doesn't even make sense that that would be 441, right? Doesn't even make sense it would be that much. So take the square root, and don't give me negative numbers either, because you're not thinking. Okay? Some common sense about the answers you put. square root of 441 is exactly 21. So A was equal to 21 feet. You will have decimals, and most of the time I'll have you round to the tenths place. Okay. All right. So here's what that next one is supposed to look like. I know it's black and white and blurry on yours, but we're asked to find the area of this triangle. Well, so the first thing we need to know is what's the formula for the area of a triangle? And I know that Orlando is so excited to give me what's the formula for the area of a triangle. Come on. How much? Base times height? What do you think? Is that right, Rusty? Yep. Base times height. Divided by 2. Base times height is just for a parallelogram. Okay? Base times height divided by 2 because a triangle is half of a parallelogram. That's why it's divided by 2. Yes. So our area formula, base times height divided by 2. So in this case, I have my base, but I'm missing the height. Okay? I don't know how tall this triangle is. I need the length of the altitude of this triangle. So how am I going to find the length of the altitude? How am I going to find h? River? How am I going to find h? Okay? If we focus on just half of this triangle, this is a leg. This h is also a leg. And this is our hypotenuse. So we're missing a leg of the triangle. 8 squared plus 8. The height squared is equal to 17 squared. And once we find h, then we can plug it into the formula because we already have, what's the base of this triangle? The whole thing, 16. We're just missing that piece right there. So we're finding it right here, 64. What is 17 squared? So minus 64 from both sides. And then in order to find h, we do the square root, take the square root of both sides. Comes out nice and even 15. I'll put that 15 there. 16 times 15 divided by 2 is 120. 120 what? Keep going. Meters squared. Squared. Meters squared. Meters is just a distance. This is more than that. This is an area. Okay? So this would be meters squared. All right, without looking at your neighbor, without asking for help, I want you to graph and plot the point -3, 5 on here, here's 0, 0, and 2, 3. And label them P and Q. You got 5 seconds. And now Q, remember the first number is X, so that's left and right. Second number is Y. That's Q, that's correct, 2, 3. Now try to draw a line from P to Q. Okay, now draw a line from P to Q, but stay on black lines. Down. Very good. Keep going. Faster.
It's off the thing.
I know. So, if we want to find the distance from P to Q, we want the length of line segment PQ, we can use the Pythagorean theorem, which is the same thing as the distance formula. Did you use the distance formula in Algebra 1?
Yes.
I think you probably did, and maybe you didn't know where it came from. But this triangle has one leg that's how long? 5, and the other leg is 2. And this distance would be our C if we did A squared plus B squared equals C squared. So 2 squared plus 5 squared should equal C squared. That's 4 and 25. So 29. I just need to take the square root of 29. And if it doesn't come out even, or round, it doesn't say where to round to, but what is the square root of 29? Okay, 5.385. Is it 5.385? Okay, then I won't write it as 5.38. 5.39 or 5.4. Let's call it 5.4. 5.4. That's the distance. Length of 5.4. It doesn't give me inches, doesn't give me what units I'm in, so I'm just 5.4 units. Kind of generic. All right, so now let's work backwards. Sometimes they will give you a triangle and not tell you whether it's a right triangle or not. It'll kind of look like it, but they won't tell you whether it is or not. Is that a right triangle? You don't know. I didn't put the little square there, and you don't have any numbers. Okay? If I write this, is it a right triangle? How do you know? Can I find out? How? If C squared is equal to A squared plus B squared, then the triangle must be right. So, the longest side is the only one that could be the hypotenuse. So, if anybody is the hypotenuse, it would be 6. So, I'll rewrite it the other way. If 6 squared is equal to what looks like they could be the legs squared, the square, some of the square of the legs, then it's a right triangle. Is it? Really? Since when is 36 equal to 9 plus 16? No. So no matter how closely I draw the picture, making it look like a right triangle, if I don't put the little box down here in the bottom, You don't know for sure unless you plug the numbers in. And if the numbers work, then it is. What did it need to be? Sure. It needed to be 25, which means this side would have to be 5. If it was 3, 4, 5, then it would be a right triangle, because 3 squared plus 4 squared is 25, and so is 5 squared. This would be a right triangle. If these were the numbers, it would be a right triangle. Okay? But if it's a 6, it's not. If it's a 4.5, it's not. Okay? So if c squared is not equal to a squared plus b squared, then that triangle cannot be right. And if it's not a right triangle, what could it be? Seriously? That's my boss right there. You say something like that, I'm going to get fired. What's up? Anybody for career day? No. I don't know. Let me think. If it's not a right triangle, what is it? Orlando? If it's not a right triangle, what is it? It's either a what or a what? Obtuse or cute. Thanks a lot. Then the triangle's right. But if c squared is bigger, which is the situation we had with 3, 4, 6. So a 3, 4, 5 would look something like this. Okay? 3, 4, 5. If I make that 6, and I keep the other two at 3 and 4, 6 is going to be something like that. Okay? So in order to keep the corners together, I'm going to have to move that open. I'm going to have to bring this down. And so what happens to that 90-degree angle? It turns obtuse. In order to reach. So when c squared, when c is too big, you get, oh, that's down here at the bottom, that's obtuse. Because that would make 6 squared is greater than 3 squared plus 4 squared. 36 is bigger than 9 and 16, bigger than 25. So when 36 is bigger than the sum of the other squares, it's obtuse. Go back to a 3, 4, 5. Okay, here's our 3, 4, 5. If I make that hypotenuse shorter, now I can't make it too short. I can't make it 4, because then it wouldn't be the longest side. Okay? So, there's no way it would be a right triangle. If I make it, let's say 4.5. That's going to bring it in about that far. Okay? That's more like 4.5, maybe. So this one, in order for them to match up, I swing this up. Okay, I got to swing that one out more. Got to swing this one up more. Swing that one out more. Oh, and finally I get them to meet. And this angle, yeah, this angle went from a 90 to an acute. So 4.5. 4.5 squared is less than 3 squared plus 4 squared. How do I know? What is 4.5 squared? 4.5 squared. 20.25. So the square of what could be the hypotenuse, the only side that could be the hypotenuse, the square of that is bigger than the sum of the squares of the other two sides. So it must be acute. The altitude. What are we going to do with it? I won't need to divide that. But this altitude, I can just focus in on 1/2 of this isosceles triangle. Because if I can find the length of this other leg, then all I need to do is double that, and I'll get the whole base distance. Okay? So you got one leg that would be 6, one leg that's unknown. We'll call it B, and it's got to equal, so 6 squared plus B squared has got to equal 8 squared. And once you find B, double it, call that B. So X will be 2B, or not B. That's what